right, so let's get into it. Just the obligatory introduction slide, we'll go through it. So my name's Michael Generakis. I am the director for Spider Labs in Asia Pac. Also involved in Sec Talks Brisbane. Come along, fourth Thursday of every month. I've been asked to put this in. I've also spoken at the equally as good WACON, Flat Ducks, and Julian.
So I'm currently the application security engineer at seek.com.au, for those who don't know that, and also lead the OWASP Melbourne chapter. So we do regular events for devs down in Melbourne. And I used to be a developer, but probably haven't coded for 3 or 4 years now, so don't really consider myself a coder anymore.
Cool, so I'm going to do Pat's job and tell you what this is about. So basically, there's a bit of hype surrounding crowdsourced security testing and bug bounties, and there's been a lot of sort of I guess outlandish claims in a lot of ways. Many have claimed that traditional penetration testing or security assessment is dead, and there's going to be an Uberization of the industry, and we're going to be basically Uber drivers. But most of the discussion on this has either been from the bug hunters themselves and their methodologies, and that's really cool. So if you know Shubs and Nafi, they do some really great presentations on that. Or they're from the bug bounty companies themselves, and it's a bit of a mixed bag. So some of the ones that may run it on their own, they do some pretty interesting presentations. And then you've got the sort of the bug bounty companies that perhaps a little bit more biased in their coverage, but very few address the point of view of an organization trying to manage their security. So this is really what this is trying to address. We want to point out some of the realities of running a bug bounty and where they fit in an organization's security testing framework. So just a bit about bug bounties for anybody who's been living under a rock for the last 3 years. The concept is simple, right? It's just a mechanism for security researchers to submit a bug to an organization, usually with some incentive tied to it, right? So usually cash or kudos or like shitty t-shirts or something. And it was pioneered and established by the likes of Mozilla, Microsoft, and Google. But more recently, there's been various startups that have entered the space offering to host or manage bug bounties for organizations and offer them to, offer access to the platform and their platform of security testers. So companies such as BugCrowd, HackerOne, Synack, and the likes of those. We refer to them in this presentation as HAS providers, so hacking as a service. And that's in contrast to where we've referred to, say, traditional, say, pen test providers.
Just out of interest, who has run a bug bounty program before? Okay, so like 1%. Awesome.
Well, it's good. You might
This is great.
hopefully learn something. So just quickly, there's a few different types of bug bounties. So you've got your public bounties. So that's a bounty program that invites anybody to participate in it. It's just open to the public. You've got private bounties, which are invite only. Usually, you get invited, or a friend refers you, or maybe you submit a bug anyway, and they'll invite you into the program. And then there's time bounties. So it's usually limited to the HAS companies that do manage bounties. But a time bounty is just a bounty, typically a private bounty, that is only open for a short period of time. So just to summarize it, right, bug bounties are essentially just pen testing, but with a different economic and resource model tied to it. And that's what makes them interesting. So, I mean, I'm not saying that as a slight. And one of the things I want to be clear with this presentation, it's not a hit piece on bug bounties, it's not a hit piece on pen testing or anything like that. We're trying to provide a pragmatic view to where these activities fit for most organizations. So, the hype. So, why you should pay attention. So, as I mentioned, there's been a lot of hype surrounding bug bounties, and a lot of it is driven by the sort of the VC-funded Silicon Valley marketing departments. But the bug bounties and the HAS providers as well represent some interesting innovation in the security testing space, and really offering some new perspectives and some new ways of doing things. And so it can be a great complement to your AppSec program or your information security program. And if you perform security testing, you really should explore the benefits and the trade-offs, and that's something we'll hopefully cover off. So just to set the scene, right, just speaking more generally in terms of security testing, this is taken from the TrustWave security testing report. But the key takeaway from this is, like, if you look at the top 3 challenges, they're talking about not enough staff, not enough skills, not enough budget, right? And so this is a theme that we see over and over again. The presentations this morning speaking about the skills shortage and things like that. It is a real problem, and yeah. This is essentially how it manifests itself, right? You have a tech team or an infrastructure team, and then you've got a couple of guys having to deal with security for the entire organization. Cool.
So I guess the other reason Seek decided to look into bug bounty programs was also because we've kind of done a bit of a shift, and most of you might be aware that we're moving from like the waterfall 3 to 6 month deploy cycles, especially for the online technology scene, but also other industries are starting to move into this agile DevOps environment. So we went from 3 to 6 months deploy cycles plus maybe 1 stack per company, so everyone had to use .NET, SQL Server, and all those types of like that 1 stack. Whereas now we've actually moved into a continuous delivery environment, especially at Seek, and other companies are starting to move into that. We're actually deploying quite frequently, using agile practices, and the developers essentially have a team around them with PMs and everything, that they're all autonomous doing their own project. So essentially they're moving faster as well. Between then and now, nothing's really changed from the security perspective. There's still a bad ratio essentially between security and dev and practice teams. Next slide. So essentially, as probably the talk mentioned this morning as well, we're trying to move towards a DevOps environment. We also want to somehow put security into that environment. So we're adding security as one of those elements that the dev teams have to consider during their development, mainly because of that skill shortage and also moving faster. There's no room to put manual pen testing or manual code review or manual security reviews during the development process anymore. So we have to push it into them. You start having things like security champions in each team, so that they are your into those different teams and they come and advise. So the security team ends up being more of an advisory role rather than a hands-on role in the teams. That's kind of the end goal that some of us see the industry moving. That's where we're moving as well at Seek, but we're not quite there yet. I don't think many companies are at the moment. So at the moment, we're deploying about 30 times a day to production. So that might even be some teams not even using a staging or test environment. They're going straight into production. Obviously, there's some sanity tests going in there as well, and there's also lots of automated tests going through. But essentially, that's last year's figures as well. So we're actually seeing a ramp up even more of that. So we have to figure out ways of fitting security into a deploy that's happening once a day and trying to figure out how to best achieve that. We also did a bit of an experiment last year where we wrote down on notepads all the different languages, frameworks, and practices that we use at Seek. This is kind of the whole 1 stack versus each team is autonomous and gets to choose their own languages and frameworks. So we found out we have about 150 different languages, frameworks, and libraries that are getting used at Seek in the different teams. So you also have that complexity problem to deal with as well, where historically, you have 1 source code analysis tool, for example, that would take care of all your Java source code analysis. Now we have 5 or 6 different languages to deal with, and not all tools are supporting all those languages, so you get into difficulties of implementation there as well.
Cool. So hopefully that sets the scene of some of the challenges organizations are facing. Obviously, Julian's got good context at Seek as well. And so, thinking to some of the advantages and some of the promise of this model, the way that bug bounties address the skill shortage is via crowdsourcing, right? So what that does is it unlocks access to a vast resource pool. So BugCrowd and HackerOne claim that they have testers in the tens of thousands, but I mean, in theory, the resource pool is potentially much greater than that. It could be anybody. Even private invite-only bounties can give access to a larger and more diverse resource pool than you might traditionally get from a pen test provider or an in-house team. And so going back to the previous slide, the idea is it kind of balances it out, right? It supplements your team in a significant way. So yeah, so to summarize the benefits, right, it scales well. You can tap into hundreds of testers instantly. There's diverse skill sets, right? So one of the interesting elements of the bug bounty model, and we'll discuss in a little bit more depth, but researchers will specialize in certain classes of bugs and focus on finding those because the ROI is better for them. And it can lead to higher quality bugs. And just to give a breakdown of where a lot of these testers are coming from, this is from BugCrowd's 2016 State of the Bug Bounty report. There's a very diverse range of countries where the testers are from. So you're getting access to not only diverse skill sets but also diverse cultural backgrounds and the like. The other side of the bug bounty model, which is interesting, is the result-based economic model. So, basically, when you run a bug bounty program, you're only paying out based on successful bug submissions. So that is genuine, validated, non-duplicated vulnerabilities. And it flips the switch on how most companies pay for vulnerabilities, right? So usually you're paying for the resource's time, be it an in-house resource or a third-party provider, and you're paying for the time to find the vulnerabilities and look for the vulnerabilities rather than the vulnerability itself. And to me, this is the real innovation of the model, and it opens up a lot of potential and some interesting elements. So I think to boil it down, the central benefit of the result-based economic model is that you don't have to make as many compromises, right? So, compared to traditional pen testing activities. So you don't have to limit yourself to a small number of testers because you're not limited by paying for their time. If you're paying for their time, if you add more testers, it's more time. You're increasing your costs. You don't have to limit yourself to a set time frame because again, you're paying for the time. The more time, the more cost. And you don't have to limit the scope to the same extent because again, you're not having to manage the costs based on the amount of time it takes.
Cool. So another question, everyone gets really excited about running a bug bounty program, but at the end of the day, you do have to ask some really tough questions, especially as an organization, to figure out if it's even appropriate in the first place to run them. So some questions like, do you have the security people in the first place to be able to triage and actually fix these bugs internally? Because one of the big problems is if you have all this big stream of issues coming through the bug bounty program, if they're just sitting there dormant for 6 months to a year not getting fixed, then you run into some issues as well. The other question is, what's the security maturity of your systems like? I mean, if you've never got this website pen tested and you unleash the bug bounty crowd onto it, you're going to be paying for bugs that, repeat bugs like domain takeovers, XSS left, front, and center. So it might end up actually costing you more than a regular pen test. So you have to be aware of what the maturity of your websites are a little bit before you consider a bug bounty program. And the other thing is about fixing issues as well. Obviously, you need to be able to fix them in a reasonable amount of time. If you're in an organization that's time pressure or your deployments take quite a long time, if you get a Sev1 issue reported, you want to be able to fix that pretty quickly. So do you have the internal processes to be able to handle that as well? It is. Woo! It's like my favorite slide, sorry. Trying to make sure that works. So how fragile your systems are, that's another question, because especially if you're going to be testing on production systems, which most bug bounty programs are run on production systems, most companies don't have a publicly available test environment that's at least synced up with production, and even that in itself, exposing a test environment, can be a very difficult process for most organizations. So at the end of the day, you end up having to decide whether you want to test on production or not. So essentially, if you have a very high uptime requirement for your website, or it's a very fragile system, those bug bounty researchers are going to smash your site and most likely take it down if you're not have some sort of stability on the website to be able to handle that traffic. So that's something to be aware of. And the other part of it is, do you have the ability, especially if you're testing on your production websites, do you have the ability to detect and then block certain attacks? So if your customers are getting infected, or if an attacker's gone rogue or something like that and smashing you with a denial of service attack, do you have the ability to block IP addresses, stop those attackers from taking down your site as well? So there's a few questions that you do have to answer.
Yeah, so, and just to explain this GIF, that's Yahoo and that's Naffy. So, yeah.
So to do a proof of concept, because we didn't know about a bug bounty program at Seek, whether it was going to be valuable or not, and it's also a very hard decision for a company to say, yeah, let's let loose 50 hackers from around the world, we have no idea where they are or who they are, to try and find bugs on our website. So we had to go through a bit of a process of convincing stakeholders and other people, other management groups to essentially trust us that this is a good thing for Seek. So one way of doing that is you can do a timed bug bounty program with these HAS providers. So we spent 2 weeks doing essentially like a bigger pen test. So it's a 2-week program with 50 hackers invited to the program, so it wasn't made publicly available to everyone, it was an invite only. And we had about 3 or 4 apps in scope during that 2-week period. One thing to mention is that with bug bounty programs, you have a brief that gets sent out to all the researchers that are invited, and that essentially lists out all the what's in scope, all the requirements, what not to test for. So we had a lot of things like don't use burp scanner, because obviously we can run that in-house. We want to pay people to actually find bugs manually. But you can essentially specify what bugs you don't want, what's out of scope. So if you have a third-party provider like Stripe or something like that, you can say they're out of scope, so please don't test them. There are some issues with that as well, like as we'll get to in some of the lessons learned a bit later on, where this is not a perfect solution, but it's 80 to 90% there. So during that 2-week program, we had 104 issues reported in total. Out of those, about 40 of them were verified and non-duplicate issues. So those are what you're getting out of the program, essentially. The rest obviously takes a bit of resource time to triage and all that type of stuff, which is we'll talk about a bit later on as well. And out of those 40, we had 3 high issues, and they were rated proper high issues, not like reflected XSS that you might get on a pen test report that I also used to do back in the day. So those are proper highs, like hands down, teams are fixing the issues within a week type of thing. And then we have 7 mediums, which we try and get fixed within a month or so, and then lots of lows as well, obviously. And interestingly, the OWASP Top 10, has anyone not heard of OWASP Top 10? So essentially, we found that 97.5% of all the issues found were categorized in the OWASP Top 10. So it is a really good place to start. If you're thinking about running a training program, even though everyone says it's not the only issues you should be teaching, it is certainly a good place to start, because obviously the metrics that come from the OWASP Top 10 to build that list are from industry metrics as well. So we proved that pretty significantly in here. Yep. So we invited 50 researchers for this program. Obviously that's, you don't have to do 50, you could do more or less depending on what the websites are, how many you've got in scope, all those types of factors. Out of the 50 though, only 15 submitted issues and only 12 researchers submitted valid issues. So even though you're inviting 50, technically speaking, you're probably only getting about 15 out of that 50 that are actually looking at your site at one point. So even though you're inviting 50 or 100, you might only get a smaller amount. So we expected to get high volumes of traffic coming through because of 50 researchers all hitting the site at once. That wasn't necessarily the case, and I've got a graph of that a bit later. So out of the 12 researchers who submitted valid bugs, most of them came from India, and then followed by Afghanistan and a few of these other countries. So there's a few reasons for that. We saw that a lot of the researchers came from the US in that bug bounty report. One reason for this is we started off our program in quite a low reward range, but for countries, because it's all paid in USD, so for countries whose dollar is quite strong to the US, it's worth their time, whereas other programs, people in the US or Australia might not think that's worth their time to spend to get $1,500 for a P1 issue, which is, in the scheme of things, not a lot of money, but for those guys, it is a lot. So you can still have an effective program without having that high reward range. And this was the distribution of the rewards paid out. So there's that P1 issue that came through, a few P2s, and then onwards to the lower issues as well. So mentioning about time spent versus how much money they're making, this is $2,500-ish that one researcher got for 2 weeks' work, or even less. He probably didn't spend 2 weeks total. He probably spent like a weekend and a bit. A lot of these researchers aren't full-time. They're going to be doing it on the weekend. So for most of these guys, I mean, even after the 750 mark, that's quite a decent wage for that 1 to 2 weeks worth of work for them. As far as the traffic we saw, we were a bit worried that it might be quite a significant hike, or we might not be able to handle the traffic. Seek's websites do take a fair bit of traffic to begin with, so I guess for us that little step up isn't that much compared to what it was before. So the blue bar is obviously before the program, and then during the program is the red bar. So for both of the sites that were in scope, the 2 main ones, we didn't see a very big increase in traffic. That's also because we said you're not allowed to use automated scanners, and for anyone that was causing major issues, we could block them with controls like the WAF, for example.
It's also because it was a private invite-only bounty, and there was only 50 people, but there was also only 14 people participating in the end, so the amount of traffic generated by 14 people isn't going to be, too devastating. So it could be a good way to get your toes wet.
So that was back in May last year. We ran that program, and then in November last year, we started an ongoing program because we found obviously the success of the program to be worthwhile. So we decided to step it up a little bit. It's still private, so it's not publicly available. It's invite only, but we choose how many people to invite over time. And we started again with initial 50 researchers, and we've upped that to about 100, 150 since then as well. And it's obviously ongoing and on our production systems because we found that we could control what the researchers were doing enough so that they didn't interact with customers and do malicious things on the website that we didn't want them to do. And we added a few more things in scope as well because of the longevity of the program. And the more that you can put in scope and the more that's ready to be put in scope, the better, so that the testers can find more. So this is a submission timeline. It was actually pretty interesting. When we started the program, it was probably actually about here. I think this graph's a little bit wrong. So we had a massive spike initially when we started the program, and that's a lot of the low issues coming through. And then it wasn't until down the line here, like within a week or two, where we started to get some high issues. So it does take a little while, and then obviously it's dropped off quite significantly until we added more researchers down there. So after the researchers get bored or they've done enough testing on that one website, they'll probably go to another program where they can try and find more stuff. So you do have to keep those incentives going, otherwise you won't have much traffic here. And you can also effectively shut down the project like we did over Christmas, where we just didn't invite any researchers, and that way we didn't have much traffic coming through while there wasn't many teams or people at work to fix the issues that were coming in. So there are ways of kind of having those options. And this is a similar graph so far, what we've had from the ongoing program. We've had one P1 and a few P3s come through. Since I made this slide, we've had a few more, one P2 come through and things like that. So we're still getting pretty high quality issues coming through. And essentially what we can do from here is increase the reward range and invite more researchers to get that continual issues coming through and different types of issues. As Mike mentioned before about the diverse skills, the more people you invite, the more likely it is they're going to have different skill sets to test for different things in different parts of the website. So obviously there's quite a few risks involved in running a bug bounty program. A lot of these you'll have to get past your management teams to be able to get the program initiated in the first place. So here's some of the mitigations to some of the risks that we had. Obviously, bringing down or disrupting production websites, you have to make sure that, if the researchers can run a burp scan, and that'll bring down your site because it's very fragile. You need ways of either blocking that traffic. We have a web application firewall that we use to cater for most of the burp traffic because most of that will get blocked because it's just standard basic traffic. We can also obviously block the IP address of the researcher. And also in the bug bounty brief, it specifies that you're not allowed to do these types of denial of service attacks. So between those three things and the controls we had internally, we were happy with that risk. But obviously that's going to be different depending on your organization. The other one is obviously that they can interact with your customers or steal customer data, and that's probably the biggest one I hear when I ask other organizations why they don't run programs. And the answer to that for us was lucky we actually took out of scope one application that was just really, really difficult to test without interacting with customers, and we have to use, obviously, regular pen testing for those types of sites. So that's one of the use cases where a bug bounty program is probably not going to fit. There's also internal controls we have for fraud and things that will pick up interactions with customers before they happen, so we're able to continue testing websites without having that problem as well. So the other issue is obviously the researcher could take that bug they find and go sell it on the black market or use that exploit to get sensitive data and things like that. I guess the main comeback, if you will, for that one is that obviously real attackers can already access your public systems. So, focusing a bunch of good guys who have a good reputation, because if you're running a private program, these HAS providers will actually invite mainly the researchers who have a really good reputation over time of finding and submitting good bugs. So it's less likely that you're going to attract the bad guys to your site. Again, obviously anyone can just attack your site whenever they want. So the other mitigation to this is obviously if you can get good people to submit the bugs, then you're fixing the bugs before real attackers can find them as well. And also giving them bonuses or increasing the reward range so that it's worth them submitting the bug rather than going on the dark markets to sell that off essentially. So making that incentives there as well can be a benefit if you're worried about that. And obviously as well, if they find a bug, they could, normally they'll do a blog post about it or they'll tweet it about it, say, hey, I found this issue on Seek or whatever. This is where the issue, if you can quickly fix the issue essentially, then that mitigates that problem a little bit, because at least if they do disclose it, it's been fixed already. Obviously in the obviously in the brief it says not to, and it's against the terms of service of the program, so they can get kicked off. They'll also drop their reputation score on those HAS providers, which is a really big thing for researchers, because it means they get invited to more programs, and it also means it's good for their CVs and stuff like that. So that's another incentive not to do that. And they won't get paid, so that's obviously the biggest one.
So just a thing on that with the reputation score, and we speak about private bounties. From the bug hunter's perspective, the most lucrative bounties are always private, and so that's usually, the invite is usually derived from how high their reputation is, and the quality of the bugs that they submit, and the quality of the reports that they do. So it's unlikely that they would do something like this because of the potential loss of income in the future.
So I guess after we've run the one on-demand or time-based program plus the ongoing program, there were a few lessons learned during that piece. One of them being that it's really hard to control the researchers in a fine-grained control like you would with a regular pen tester. So obviously if the pen tester's there on site, you can say, please don't touch this exact page, or please don't do this, or don't interact with customers, and they will normally not do that. Whereas with the attackers, some of them aren't as skilled in figuring out a corporate environment or understanding that certain things are bad, especially because a lot of them don't speak English very well because they're coming from countries where that's not their first language. So if you make the brief really complicated and have all these limitations, then they're probably not going to read it in the first place. So that's one thing we learned. This is a graph showing we trialed allowing the bug bounty researchers or telling them to put a specific user agent string to said bug crowd seek or something like that, so that we could indicate which were bug bounty researchers and which ones were real attackers coming through. Because obviously they're coming from their own IP addresses, you don't know if they're real or not. This graph is showing 2 weeks before the program. This is 2 weeks, this is the stats on our WAF, just detecting blocks, essentially. So this is the red bar showing the blocks increasing during the program, and this is the ones with the user agent string. So you can see quite a lot of researchers didn't use the user agent string, which made it a bit more difficult for us to determine if they were real or if they were just testers. This might be a little bit difficult to read, but essentially you have to deal with things like this where researchers will go out of scope and they'll report a low severity or even whatever severity issue on a site that's not deemed in scope. You don't really want to, some cases you might pay them out because they found a really decent issue, but that's also promoting bad behavior. If you've specifically said, I don't want this website being tested, then if you pay them out, they're going to continue to test that website. So it's a bit of a hard one to manage. But in this case, he found an XSS exploit on a website we didn't care about, we didn't want to pay out for because we hadn't had that maturity test on it like we have our other applications. In this case, it was through BugCrowd, and the guy managing our program said, thank you very much, I really appreciate your effort. This is out of scope, so sorry we can't actually pay out for this issue. And then we get something like this in response. He's obviously decided that he wasn't happy with that result because he's done all this effort. He's got the exploit. He's sent it to us, and he thinks we're obviously not doing good by him by paying him out. And because we gave him a -1 score as well, because it's out of scope, because we don't want to promote that behavior, he was getting a bit angry. I hadn't actually seen that whole thread until this point, and I was actually going to pay him out for this issue, but then I saw this and I was like, well, you made an easy decision. This is another example of things you have to manage, so all the low severity issues, all the issues that you don't care about, like stack traces. It's a little bit hard to read, but essentially he found a XSS plus full server path disclosure. It turned out just to be a .NET stack trace on a website, so it was an information disclosure. Didn't have anything too bad on there, and it said potential XSS, so he hadn't actually done the XSS, he just thought there might be XSS there. So you still have to go and validate that issue, obviously, because if it does turn out to be XSS, you want to be able to pay him for that. So there is that kind of resource time spent. So I guess here's an overview of all those different lessons learned. Limited control was one we talked about, which is definitely one of the challenges, especially if you're coming from a company that has a lot of sensitive actions on your website, or if you're in finance, you have a lot of financial transactions you don't want these researchers to test. That can be a bit difficult. Unsure whether the attacks are coming from real attackers or not. There are a few ways around that, so you can actually send them all through a VPN, so they all come out as one IP address, and you can just block that IP address straight away. But that obviously has the consequences of increasing the friction to get into your program, and there's so many other programs around that will probably not bother participate unless there's some really good incentives to come and to join. Obviously, you can incentivize new features of the program. So if we are releasing 30 times a day, how do we know those 30 changes are getting tested via the bug bounty program? And the short answer is you don't know. The only thing you can do is direct them in certain areas occasionally by giving bonuses for testing in certain parts of the website and for certain features. And you want to respond to every researcher in a pretty reasonable time frame, otherwise they're going to get annoyed. And that's just, you want to build up that relationship with the researchers because they're doing a really good job for you normally. So you want to have that respectful relationship. And also if you essentially piss off one researcher, they're going to go tell all their other friends to not partake in your program, and you obviously don't want to do that because you want as many as possible to test your website. The other thing we learned was also that we have an on-call model at Seek as well, so all the development teams get woken up at 3 a.m. if there's alerts coming through. So we had a few times where we got some angry DevOps people knocking on our door being like, you guys woke us up for 3 a.m. in the morning because of all these error alerts that were coming through. They didn't get blocked by the WAF because not everything does, obviously. So their website couldn't handle that traffic, and they started getting alerts because they thought their website or their API was coming down. So there's a few things like that you have to be prepared for as well, but you can manage that in-house normally.
Cool. All right, so just coming back to sort of the reality and contrasting some of the stuff we discussed in terms of the hype and the potential. So one is revisiting the economics of it, right? So the result-based economic model can be more flexible, but it's not necessarily automatically more cost-effective. So the marketing from the HAS providers, they like to compare bug bounties to sort of point-in-time pen tests, but it's not really a worthwhile comparison. As we've seen, the model is just too different. And the common price per bug measure is a trap. It doesn't really factor in a lot of the other costs that are associated with it. So given that bounties are ongoing and longer term, you probably should be modeling something closer to your total cost of ownership analysis. I know it's not like a product that has a finite life cycle, but you need to factor in a lot of other elements. So management fees. If you're using a hash provider, you're going to pay management fees. And we saw in the timeline of submissions, there were periods where there wasn't that many. So there will be periods where the management fee will outweigh the value that you're getting from it. Internal management program. So as Julian pointed out, they were using BugCrowd, but there was a lot of internal management, not just on the security side, but on the DevOps side that went into it. There's increased load on production equipment and processes. There's potential for downtime and outage, so you may need to factor that in, and potentially even diminish performance, right? So if you're not prepared for that, there may be some opportunity costs there if your performance is diminished. So the other point, as Julian mentioned, managing the incentives are also not straightforward. So you have to account for the variability of the payout. The cost is driven by the results. So more results equals more cost. So one way to get around it is to adjust, have a certain length of time in mind and adjust the payouts accordingly. But as Julian mentioned, you are competing with other bounty providers for resources, right? So if you're too low, you're not going to get good resources, or you might be getting just as one kind of resource. So in a way, you become a vendor to the testers. So payout size directly influences the quality of the testers, and the submission. So in traditional pen testing, you might pay more for low-end bugs, but you typically pay less for high-end bugs. So it kind of has to balance out, and you have to take that into account. So the other point here is compliance. It's kind of like the elephant in the room. So I know everybody here are unique, elite hacker snowflakes, and everybody wants to come and have your time and pay for your time because you're great. But the reality is, compliance drives the industry, and compliance drives the majority of testing. And compliance artificially creates economic incentives to perform this testing, which is why it's actually driving action. And just with compliance, don't necessarily think things like PCI, CBES, and external regulatory compliance. Think internal compliance. A lot of large companies have internal audits. They've got security policies. Some Big Four guy came in and charged them $1 million to write some crappy security policy, and they're stuck with it. It's why most of us have jobs, right? It's something that needs to be addressed. And compliance testing by its nature is based around assurance and verification. You're trying to determine that a certain level of control has been established and maintained. So this is why you find that the checklist approach is so prevalent. And QSA is asked to see your methodology, even if you've raised particular findings in the report. They might say you haven't written it in the methodology, so it's not. Yeah,
good luck asking a bug bounty researcher for their methodology.
Yeah, exactly, right? Exactly. And so the incentives in the results-based model don't incentivize testers to that style of testing, right? Compliance testing is about verification. So even if everything is fine, or you're likely to be fine, you still need to verify, and more importantly, you need to evidence it, that level of compliance with the control objectives. So for a bug hunter, spending time verifying controls for a company that has no ROI compared to actually chasing a bug that's going to get a payout. And you'll see this, and this is why you see some interesting bugs come from the bug bounty community. But you'll find testers will focus on finding those bugs, and they focus on the people who are most successful, focus on doing it in a smart way to maximize their investment. They're not there just taking a checklist approach. And the only way to get around it is to pay for the verification activities, but then you're going back to your traditional paying for your time approach. Liability. So one of the other big hurdles to overcome with this approach for most companies is managing liability. Most large organizations, I'm sure a bunch of you work for large organizations, you've got a risk management department, you've got a vendor management department, and this is usually where bug bounties stop in those organizations. There's a level of risk tolerance that's required at the moment. So, Seek, its culture is a little bit more tolerant to risk. They've got more of a progressive approach, and a lot of the companies that you read about that are running bug bounty programs are similar in nature, right? So even when using a HAS, you need to understand where does the liability sit if there is an issue that's caused by the tester. The standard sort of legal protections that you have, MSAs, NDAs, things like that, do not extend to anonymous testers. Enforcing action against anonymous users cross jurisdiction is probably not going to be possible. I'm not a lawyer, but I can imagine that's going to be pretty hard. And liability, so when you are dealing with the HAS provider, the liability extends only to the amount of the management contract, so not the payouts, right? So if you're paying X amount per month for the management, it extends only to that amount. And most HAS providers are in the US, so most of them are governed by US law as well. So it's another thing to take into account. There are still a lot of unanswered questions when it comes to getting more traditional organizations on board because of these. It's likely that the HAS providers will evolve to meet these problems as they try to expand their client base beyond sort of their more progressive tech companies. And it will be interesting to see how it develops. I think this is something that they're actively working on. I know BugCrowd does a lot of work with CipherLaw and those guys to try and address this issue. So bottom line, should you run a bug bounty? Hopefully you got the answer is like maybe, right? There's no silver bullet in information security. I kind of feel like we've been over this before, right? It's not necessarily for everybody. That doesn't mean that it's not worthwhile to explore. So I think this is a good slide to demonstrate that. This is one that Julian did, so I'll hand over to you. But it demonstrates that they're just sort of one tool.
Yeah,
quickly, Julian, quickly.
Yeah, 2 minutes.
It's only 2 more slides.
Essentially, the bug banning program is only one control that we have as a part of our whole application security program. So you can see that we're still doing all the other things that you need to do. We're just doing it in a bit more of an automated fashion to handle that fast release cycle time. But we still need manual pen testing, as I said, for certain websites and certain situations where we might have a new feature that comes out and we want to test that specifically before it gets into production because it's sensitive in nature, touches authentication or sensitive data. But the bug banning program is a really good way of getting that continuous monitoring because of the environment that we're in. And it also obviously scales well depending on how many applications you have.
Cool. So yeah, the key takeaways. Bug bounties have a lot of inherent benefits, but there are a number of considerations that need to be understood and accounted for, as hopefully we've demonstrated. Always evaluate against your requirements. Don't just take something blindly from a HAS provider or a pen test provider or whatever. Do your homework, understand what you need and what you're trying to get out of it, and call them on it. So hopefully this has given you some insight into some of the key considerations that perhaps are less obvious. And hopefully the experience at Seek has helped eliminate that a little bit. But yeah.